record. This is what's important. So here we are. It's the midterm exam this week. What's going to happen? It's going to open on Thursday after the Zoom call. Okay. It is due Sunday, 6/28 at 11:59 p.m. Now, there could be some circumstance where, like this weekend, you know right now is absolutely impossible for you. If that's the case, you've got to let me know right now so I can make an accommodation for you and open it at a separate time. So email me ASAP before the quiz or the exam is open. Somebody.
That's great.
Sorry, Matthew, I just muted you because you were making some noise. So if you want to talk, please unmute. Okay, sorry.
Me?
Yeah, I had some feedback from you. So, okay, I don't hear it anymore. So then for your grades, I wrote you an email about this. Check Brightspace grades. I noticed on Math Excel, I'm not quite sure how they are distributing the grades. So just make sure that you check Brightspace for the grades. Those will be out Monday if I can get it done because the test is due on Sunday, okay? Today, we are graphing secant and cosecant, which I'm going to mute you, okay? Matthew, if you need to talk, unmute yourself because you're making some noise there. Graphing secant and cosecant, which is shouldn't be too bad if you know how to graph cosine and sine. It's not that bad. Questions from the review packet. You can start asking questions today, okay? Also, you can ask questions before the exam is released on Thursday at 11 a.m. on Zoom, as usual. So that's the last chance to ask questions. Getting a little blurry there. Okay, are there random questions about what's coming for the midterm and logistics? So unmute yourself if you need to talk. All right, so let's get into actual stuff for today. Okay, so I will do blank worksheet. First of all, the opener problem. This is an old lesson back from chapter 1 or chapter 2, I can't remember. Cofunctions. Do we have questions on cofunctions? Basically, we have this concept that sine and cosine are cofunctions. So if you notice that they are equal and that these two values are complements, well, the question here is true or false. Well, if these two are complements, then the sine of 30 is equal to the cosine of 60. And when I say complements, I mean they add up to 90 degrees. So this will be a true statement because 30 plus 60 is equal to 90, okay? And then how would that apply on maybe a test question? It might look like this one. You recognize sine and cosine are cofunctions, and that if they are equal, it must be true that the argument, what's in the parentheses, 2x and 4x, they need to sum up to 90 degrees. So then that's how you get the answer. All right. Does anybody want to see me work that out or clarify anything on number 1 or number 2? Hold on, Matthew, you're leaving? Can you just tell me, oh, he's leaving, okay. This was a mistake. Oh my God. Okay. I read Matthew's question, but I wasn't sure what he was asking. The interval 0 to 90 at 45. Not quite sure what that means. So another thing on cofunctions is to recognize all of them, okay? Sine and cosine are cofunctions, secant and cosecant are cofunctions, tangent and cotangent are cofunctions. So the same type of problem would apply for that. Okay, questions on that? All right. So we've got this section 4.4, which is about graphing secant and cosecant. They are reciprocals. Secant is a reciprocal to cosine, and cosecant is a reciprocal to sine, okay? And what this is giving you a table of how you could graph it. I wouldn't recommend necessarily using that. Just understanding that in order to graph, for example, this is secant, I'm going to have to graph its reciprocal function and then go from there. So how does that work? So one, and this is outlined actually nicely on the next page, what we should be doing to graph a cosecant or secant, and actually they're specifically talking about in the form a cosecant bx or a secant bx. First, you're going to graph the sine or cosine function, the reciprocal function with that, and there should be an a here actually. I don't know what happened there. That should be a cosine bx. Okay, so first you graph the reciprocal function, okay? Then this is going to tell you where the vertical asymptotes are. Vertical asymptotes will happen, now in this case, if it's a sine bx, it's going to happen at the x-intercepts, but really it's at the midline. The vertical asymptote is at midline points. I'm going to show you this in just a minute. Step 3, sketch the graph, the graph of the desired functions by drawing typical U-shaped branches between the adjacent asymptotes. I'm going to show you that. And this is, I think the video that I sent he does a much better job than I do. He's got like good colors in it and everything. So I sent you guys that one. It has good examples. All right, so step 1, graph y equals cosine of x. All right. So to do that, we have a maximum at 1, a minimum at -1, and maybe I made that just a little too high. It's not perfect. Okay, we've got a period of 2 pi, and then it would go -2 pi if I went the other way. Okay, pi over 2. These are our 4 sections, 3 pi over 2. Those are our critical points for cosine. And now this is not the secant function, this is the cosecant function, right? Let me mirror it the other way too. So it would be -pi over 2. It would be -pi. This was not far enough over. -3 pi over 2. And -2 pi. So graph the regular cosine. All right. It starts up here and comes down to the midline. Okay. Which is going to help our vertical asymptotes. The minimum at -1. And then we've got the midline, and then it comes back up. Now that's a typical cosine. This is not secant, this is cosine. So I'm going to do a dotted graph of this, okay? And then if I did it this way, it would look like this. Just dotted, just sketching that, okay? All right, so that's what cosine looks like. Step 2, vertical asymptotes. Now this happens at the midline points. At midline points. Okay. So here's my midline, horizontal right through the middle of the graph. Then we've got vertical asymptotes are going to take place at those points. Vertical asymptote is like an imaginary vertical line that goes up, and it's basically the points where secant is going to be undefined. Just like when we did tangent, we had vertical asymptotes. All right. So we have these vertical asymptotes. What does that mean? The value for secant is undefined, so it'll approach the vertical asymptote, but it will never touch. Okay, that happens here too. And I know it's hard to see on that half. We'll focus on this half. All right, that's step 2. Step 3. Now we're going to actually sketch the y equals secant of x. Okay. How does that work? Well, it's super simple. Now, this is a reciprocal of cosine. So what's going to happen is you're going to get this mirror image, like these U shapes that go from the maximum up and they approach the vertical asymptotes, but they never touch the vertical asymptotes. It happens at the minimum too. We kind of mirror the cosine graph and have this U shape going down. All right. Then over here, it's the same idea. Now we don't have the continuation here, but it would continue like a U that way. We would have a U going down here, and I know I'm in my own notes here. So that is what secant looks like. Do we have questions on that? All right. Moving down here. Cosecant is the exact same thing. Follow the same strategy. So notice how I don't need to use this. This is unnecessary. But it does exist if you wanted to kind of map it out and look at it. So step one, we're going to graph the reciprocal function of cosecant. So we will graph y equals sine of x with a dotted line. Okay, let's do that first. So we've got the maximum of 1, minimum of -1. I've got 2 pi for my period. And break that into 4 equal pieces, pi over 2, 3 pi over 2. Okay? And then we could mirror it on the other side and go -2 pi, negative pi over 2, -3 pi over 2. Okay, so we're going to sketch sine, and it starts at the middle. It goes up to the max, back to the middle, down to the minimum, and then back to the midline here, okay? So here's my sine graph, all right? And then it's the same thing over here, except it's kind of reversed. We would be like this, all right? We would have my sine graph, okay? All right, so then again, vertical asymptotes, BA at the midline. Okay, so your midline is, this point midway through. So your vertical asymptotes go on the points where we are at the midline. Okay. Okay, do we have questions on where I get the vertical asymptotes? All right, so then step 3 is to actually sketch the graph. So we're going to sketch the true graph, which was what we're looking for, which is y equals cosecant of x. And it's pretty easy. You're just going to go to your maximum points and minimum points and create u's. And that's not, my picture is not perfect. Going upwards and then downwards, okay, from the minimum. And then this is a minimum, so we go downwards. So we approach the vertical asymptote, but we don't touch. Okay. Questions on secant and cosecant? All righty. Okay, so then if you flip this over, flip to the next side. Again, I kind of walked through this. They give a little bit of notes and instructions here about what we should be doing. So note that you're first graphing and again, this should be an A. You should be graphing your reciprocal function and then do the appropriate U shapes based on the reciprocal function. So with that, you might get something a little bit more complicated, right? It's the same idea, but now I've got secant 2 secant 1/2 x. All right, step 1 is graph the reciprocal function, same idea. So we're gonna have y equals 2 cosine 1/2 x. So graph that first, and in order to do that, I ask myself a couple questions. 1, I see the amplitude equals 2. Okay, so that means it's gonna stretch vertically 2 units instead of just 1, okay? 1/2 x, that means I have a b value. B equals 1/2. Remember, the period equals 2 pi over b, which is 2 pi over 1/2, which then will be 2 pi times 2 over 1, because you multiply by the reciprocal of the denominator, and you will get 4 pi. Oh, I have to be looking at my wrong notes over here. Yep. Make sure I'm not crazy. Okay, so I've got my period of 4 pi. So that's going to help me graph. I've got an amplitude of 2. I'm not shifting horizontally, and I'm not shifting vertically. All right, so that's helpful. So what I'm going to do is graph cosine. All right, so my period will be 4 pi. Break it into 4 equal parts. Cut it in half, I'm at 2 pi. Cut that in half, I'm at pi. Through 3/4 of the way, I'm at 3 pi. It's kind of an easy one. And then you could go in the negative direction too. Not required, but I'll show you. Negative 2 pi, negative pi, negative 3 pi. All right. Then now, because the amplitude is 2, this will be labeled at 2 instead of 1. This will be labeled at negative 2 instead of negative 1. So we've got all the parameters set, which is good. Now we are going to graph the cosine. So remember, cosine starts at the maximum, comes to the midline, and then the minimum, and then back. Okay. And then you make a dotted line like that, something like this. It would happen the other way too. It would mirror and look something like this. Okay. There's your cosine. So that's step 1. Step 2 is the vertical asymptotes at the midline. So the points that intersect the midline are going to give us our vertical asymptotes. Here we go. Vertical asymptote. Another vertical asymptote. Here's the midline again, vertical asymptote. Another midline point, you put a vertical asymptote. Okay, then we do what we have been talking about. Step 3 is you're going to graph the secant graph. What we're trying to do is y equals 2 secant 1/2 x. So in order to do that, we've got our U shape going down from the minimum, up from the maximum. Take your U shape up from that maximum, down from this minimum. It would happen here, but the graph would continue on infinitely in each direction. How about this one? So that's a little bit more complicated. Do we have questions on that?
Yeah, I'm not sure about the asymptote thing. Like what, how do you know where to put that?
Okay, so I find my midline. Are we comfortable with where the midline is?
I think so, like in the middle.
Right in the middle horizontally. So my maximum is 2, right? My minimum is negative 2. That midline is right in the middle between those. In this case, 2, right, is up 2 units. That's my amplitude. And then down 2 units from the midline. So you've got to find that middle point. Now, if this graph was like shifted up or down, it might be a little harder to see that midline. You'd have to kind of really look at it closely. So like if I had a C value on this and we added a unit, that midline, let's say I added 1, the midline would be shifted up and this whole graph would be up 1, if that makes sense. In this case, we didn't shift up or down, so we are right, midline is right in the middle, right at y equals 0, right? So where do you get your vertical asymptote? You look at the points that hit the midline, right? So that's this one on the cosine graph, to be clear. We're doing cosine. The reciprocal function. So these points are hitting the midline, and that's where you put that vertical asymptote.
Got it. Okay.
All righty. Yeah, so if this is good because, you know, it's not 100% new stuff. If you know how to do cosine and if you know how to do sine, you can get these ones. You just have to know how to find the vertical asymptote and then how to put your u's, your u's and upside down u's, all right? So any other questions on that one for whoever's paying attention here? All right, next page here. So for this one, we've got a little bit more going on. We've got cosecant, which means we're going to start with the sine graph, right? So step 1 is we're going to graph y equals the reciprocal function of cosecant. So 3/2 sine, and then it's going to be x minus pi over 2. All right, we're going to graph that first. In order to do that, I have to think, okay, a equals 3/2, which is like 1.5. So that's going to change my a value, or my vertical y-axis points, okay? Not too bad. This is a little bit something I have to deal with. I've got x minus pi over 2. Well, that means I'm moving this pi over 2 units to the right because this is negative, I move pi over 2 units to the right. Okay, if it was x plus pi over 2, I would be moving pi over 2 to the left. All right, so with that, that is gonna modify my period. And actually, I kind of want to call attention to just, in general, let's go back. Y equals A, this was a sine, and then B, x minus, let's do like this, x minus D, and then plus C. So what I'm doing here is, this is my amplitude. The B affects the period. This D value tells me if I'm moving left or right, and then the C value is moving up and down, right? So in this case, I have a D value, right? Pi over 2 to the right. Notice though, I don't have a B value. I don't have anything in front of X. So my B is just 1, which means my period is still 2 pi, because the period is 2 pi over B, and B is 1. So period is 2 pi. Okay, good to know. Then pi over 2 to the right. Well, where do I get my critical points when I graph? I get it from the unit circle. So I'm sketching. Typically, you would have your 5 critical points starting from 0, and then you'd go around 2 pi units, right? So it goes 0, pi over 2, pi, 3 pi over 2, 2 pi. However, we're shifting pi over 2 to it's going to be to the right in this case. But what does that mean? Instead of starting at 0, I'm going to start at pi over 2. All right? So pi over 2 is where we start. I can imagine that already. We're going to start on the x-axis at pi over 2. The period is still 2 pi. So I need to go all the way around 2 pi units. So my end point on my unit circle and on, this graph is going to be pi over 2 plus 2 pi. So to do a little bit of kind of side work, pi over 2, that's this piece, right? Again, I'm at pi over 2. I need to go around 2 pi. So I need to figure out, well, what's pi over 2 plus 2 pi? And then it's kind of some annoying fractions to deal with. Pi over 2 plus 2 pi over 2, 4 pi over 2. Okay, so this, see how 2 pi goes to 4 pi over 2? Equals 5 pi over 2. Okay, so this is going to go pi over 2 to 5 pi over 2. And then the points in between, we need to break into quarters again. So pi over 2, we know this from the unit circle, goes next to, this is my pi, right? Okay, the next part we go here to 3 pi over 2. All right, the next one is 2 pi, we know that one. And then again, we just found the last point, 5 pi over 2. So if we listed these all out, which I will on the x-axis, it starts at pi over 2, okay, then it goes to pi, then it goes to 3 pi over 2, then it goes to 2 pi, and then the last one is 5 pi over 2. All right, those are my x coordinates. Now that's a tricky thing I just did. Other questions on my x coordinates before I continue? Okay, so those are I got it from the unit circle, and that's what I'm putting. Remember, pi over 2 is going to stretch 2 pi units for one period, 5 pi over 2. We just figured that out. Halfway through there, think about, remember now, going back to my picture, all the way around this circle, halfway through, 1 pi units gets me to 3 pi over 2, because that's kind of how I've been doing it. Cut it in half, I'm at 3 pi over 2. Halfway in between pi over 2 and 3 pi over 2, pi over 2 and 3 pi over 2 is pi, okay? That's where I'm getting that from. Halfway in between 3 pi over 2 and the 5 pi over 2 unit, right, is that 2 pi. That's where the x coordinates are coming from. Try to find my notes to make sure I have it all good. So I would just require that you do this over one period. If you want, you can imagine it mirroring over. Let's see what happens here. So what we were doing is we're graphing this sine, all right? And it's pi over 2 units to the right. So imagine, again, my amplitude is 3 over 2 or 1.5. So it goes to 3 over 2 and negative 3 over 2. All right. So then it's a sine graph. So dotted line, remember sine starts at the midline. Got kind of a issue there in my paper. Start at the midline, goes up to the maximum, comes back to the midline, and then down to the minimum, and then back to the midline. Okay, and then we have a dotted line. All right. That's my sine graph. And I could continue it. I'm not going to require that you do. It's kind of just, this is the easiest way to do it. Okay. Then step 2, vertical asymptotes at the midline points. Midline points. In this case, again, we didn't shift up or down. So my midline again is right in the at the y equals 0, right in the middle is the y equals 0 line, right at the x-axis, right? So these points at the midline, that's where you put your vertical asymptotes, okay? Vertical asymptote, vertical asymptote. That one is kind of cut off for my own scribbles. All right, step 3 is graphing what we actually are trying to graph, which is the cosecant. Oops, cosecant. Okay, from there, how do we do it? We just go to our maximum points, create that U that approaches the vertical asymptote but doesn't touch, and then go to your minimum. It approaches the vertical asymptote downward and doesn't touch, and kind of ignore this piece up here, but that should be what it looks like. Looks like on your answer key, I gave you an even more kind of pretty looking graph to complete it. Okay, are there questions on that one? All right, number 5, this is another good kind of how does this work? This is what, and now these are good ones for homework. I could see having questions like this lends very nicely to Math Excel type of questions. All right, so we are supposed to look at this and figure out what is the equation of this graph. Okay, so right away, let's say I'm coming to this on Math Excel, right? I get my homework or my test or quiz or whatever, and I'm thinking, all right, that's got to be a sine or a cosecant or a secant, because it's got the U shapes, right? It doesn't look like tangent, if you remember. Tangent has these lines. It goes upward, and then if I were to keep drawing them, there'd be many lines kind of going like this. Cotangent, like this, and then there'd be another vertical asymptote like that. Cotangent and tangent, that's how those look. Secant and cosecant look like the U shapes. So right away, I know I'm dealing with that. The next thing I'm thinking is, I see vertical asymptotes. Remember, vertical asymptotes are at the midline, right? So, and then I think, all right, the midline, now there's a bunch of things to think about. The midline is halfway between this point, right? This would be the maximum of sine or cosine, and the minimum, 1 and -1. So that means this is my midline right here, which is familiar, x-axis, right? So that means this is the midline of my sine or cosine here, right? And these points are hitting that midline. Okay, so then I'm thinking, well, this is the maximum. I'm trying to figure out, is it a sine or a cosine, which would determine secant or cosecant. So if this is the maximum, this is the minimum, it looks like a sine to me. I can see it right here. I could see, oh, and this, I'm sorry, this is a vertical asymptote too, right? I didn't quite notice it because it's on the y-axis. This is happening, this looks like a sine. It's going up, down, back to the midline, down to the minimum. That looks like a sine graph, right? So I sketched that in and I realized, all right, I'm dealing with a sine. It's a sine graph. All right, it has an amplitude of 1, a equals 1. Now something that's different, it's not shifted up or down because the midline is on the x-axis. All right, I noticed that the period is 4 pi. Now that's different. Period equals 4 pi. All right. What else? Are we shifting left or right? No. And this is a typical sine right here with an amplitude of 1. It's just that the period is different. So that's going to mean I have a b value that I need to deal with. Remember, the period for sine is 2 pi over b. Well, we just determined that the period is 4 pi. 4 pi equals 2 pi over b. And that now I solve for b. So I'd get 4 pi times b equals 2 pi. Hopefully we can do that algebra. Okay. Divide by 4 pi on both sides. The pi's will be gone. 2 over 4, this is all gone. I get, let me just do b equals 2 over 4 is 1/2. Okay, so final thing that we have here is if it's a sine, that means you take the reciprocal of sine. So y equals, remember a was 1, so we don't have to worry about a. It's a cosecant, and then the b is 1/2. So 1/2 x. That should be it for this one. Questions on number 5. Okay, that's A. We can do B. Now B is a little bit interesting because I'm noticing I've got my maximum here, I've got my minimum here. Now the maximum of a sine or a cosine, I'm not quite sure which one, right? That is interesting. The minimum is at 0, y equals 0. The maximum appears to be at y. Can you guys hear me?
Yeah.
Sorry, I got disconnected. Sorry about that. I'm going to hit pause and then I'm going to record again. Okay, I'm recording again. I don't know what just happened there. I guess I lost internet connection. Let me pin my video. All right, so we're doing this one again. So this is our minimum is at y equals 0. Our maximum is at y equals 2. That puts the midline here. Okay, that means that we've shifted up 1. If this is a sine or a cosine that we're going to sketch, which would lead to a secant or a cosecant, I know that the midline went up 1. So I have a C value of C equals 1, right? So, and then be careful. Remember, the vertical asymptotes are at the midline points. So that's where that midline is going to help you draw if it's a sine or a cosine to sketch. So what I'm seeing here is the maximum would go down and then back up like this. And then that to me looks like a cosine, right? Cosine starts at the max, goes down to the midline, minimum, and then back up to the midline. That would be a cosine, which would lead me to this being a secant, right? Well, my A equals 1 because my amplitude here is just 1 up from the midline and 1 down. So A equals 1. I'm not shifted left or right, so I don't have a D value. My period, all right, well, that's interesting. Do I have a different period? I'm starting at 0. I go to pi over 2. The minimum, it looks like it's in between pi over 2 and 3 pi over 2. And then here we're at 3 pi over 2. I think this is just a regular period, and then the maximum would be at 2 pi. And I could figure that out because these are chunks of pi over 2. This would then be what's halfway in between 3 pi over 2 and pi over 2 is pi, right? Going back to this picture from earlier. Pi over 2 to 3 pi over 2, halfway in between is pi. So this would be a pi. And then that's halfway through this whole thing. And then the final end of your period would be at 2 pi. So your period is 2 pi, which means your B value is just 1. All right, because it's a cosine, this is going to be a secant. A is 1, so I don't have anything in front here. And then I don't have a B value, so it's just X. But that I do have a C value. I'm adding 1 to it. So this is your final answer for that one. How do we feel here?
I have a question.
Well, okay, great. What do you got?
So can you explain like why is it just x?
Why
Maybe.
isn't a b value, right? Okay, b is 1, meaning there's an imaginary 1 in front of x, because the period is still 2 pi. Now, that was a little bit tricky to figure that out. Let me go. We were given something that looked like it was, imagine, just don't even think about the secant, think about the cosine. It was pi over 2 and 3 pi. Sorry, I have to recreate this. Pi over 2, and then we had 3 pi over 2. And our cosine was hitting here, 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 and then back here. This is pretty much what they gave us, and what we determined was this cosine went down. Now, they didn't label this for us, but we had to figure it out. This is the midline, right? So this cosine is not quite complete. It's going to go up another right here, which they didn't give us that value either, right? But what I do know is that this period from 0 to whatever this value is cut into fourths. So basically, whatever this is, pi over 2 is 1/4 of that. And 3 pi over 2 is 3/4 of this. Okay, so is that starting to make sense where I'm getting these values from?
Yeah, I got that part.
Okay, so I'm basically imagining, all right, we started at 0. I'm going back to my picture. And I know that pi over 2 is 1/4. So pi over 2 is 1/4. 3 pi over 2 is 3/4. 4/4 is going to be 2 pi. So I can tell by breaking this out that this is going to be 2 pi, and that's my period. To do one cosine on this, my period, it takes 2 pi units to do one cosine. All right, so because of that, the period is always 2 pi over b. Period equals 2 pi over b. Well, my period we just determined was 2 pi, right? 2 pi is equal to 2 pi over b. Well, b equals 1, right? So there's nothing in front of x because there's like an imaginary 1 in front of x right there, if that helps.
Yeah, I just needed to see the math like you just showed. Thank you.
Okay, no problem. All righty. So this is the whole lesson that I have prepared, and I'll just leave that without the 1 there, on secant and cosecant. I do recommend the video, and this is also my opinion on, you guys, again, if you were in person, I would make you do this. I would make you draw it. But now, instead, they'll be more like, okay, look at the graph and try to figure out what it is. And some of them are multiple choice. Now, especially the multiple choice, the process of elimination should help you quickly with those. And also, I recommend that if you're doing a problem like that, you can hit a plus sign and it blows it up. That will definitely help to make it look bigger. And then start eliminating, right? Like, for example, there's a tangent problem on your homework and potentially a test where, like, I have options, and one option, goes upwards, right? And the other one goes downwards. Well, based on tangent or cotangent, you can quickly eliminate some of the options, right? If it's a positive tangent, it should be shaped like this. If it's shaped downwards and it's a positive tangent, you can eliminate. That's not going to be right. So there's a lot of ways to quickly, without having to graph the entire thing, you can quickly determine which ones are not correct. That absolutely should help. So you might get intimidated. You look at a problem and say, oh my goodness, what is all that? But then you can quickly eliminate some answers. I'm thinking about like your review guide. There's some questions like that too. Anyway, this is this lesson. Before I take other questions on the review guide, are there questions on anything with, secant and cosecant? Now, I'm confident that I've gone over everything on this video.
I have a question about, like, when you're like in the number 5, when you're just like sketching out to see if it's like sine or cosine. I mean, to me, they look the same. So how do you differentiate?
What's the difference? What's the difference between sine and cosine? Is that the question?
Well, like visually, like, because yeah, like number 5, you see how like when you just like sketched it out like with a dotted line just to see like,
Yeah.
all right, where is it going? I mean, to me, it's hard to differentiate which is which. I would probably end up putting, you know, sine for cosine, and then it would be wrong.
Yeah, you've got to know the difference. Very important. So let's go back. Sine, just a regular sine. You have to understand what sine looks like versus cosine. This is imperative for this section. So sine, always, so it's, they both, let's go what they have in common, okay? They both have 2 pi for the period. They have the same x coordinates, cut in half, cut it, basically you cut it into fourths. And this is all coming from my unit circle. This is pi over 2, this is 3 pi over 2. Okay, they all have the same x coordinates for a regular sine or a regular cosine. They all have the same minimum and maximum on the y. 1 and negative 1. 1 and negative 1. Those are the max and minimum. But sine begins at the midline, goes up to the maximum, comes back to the midline, and then down to the minimum, and then back to the midline. Sine looks like this. So this is really important. Understanding it starts at the midline, right? And it goes up and down, and then it starts like, it's almost like,
I see.
yeah, and then we've got cosine. I'll talk more about it. Cosine starts at the maximum, okay? Goes down to the midline, and then down to the minimum, back to the midline, and then up to the top. Okay, so this, oh, I missed my spot, but that's a cosine. Try to hit it. All right, and you'll notice sine and cosine are shifts of each other. If I took, like, you'll notice that cosine is right here, right, on the sine graph. It's just shifted over pi over 2 to the right is when the cosine begins. This, you know, this is like an upside down sine happening right here. They are each other shifted over, if that makes sense. But the truth is, this is the sine graph. But when you don't shift it any direction, it starts at the midline, goes up, back to the midline, down. That's what a sine looks like. Cosine looks like a U. If you don't manipulate cosine, it looks like a U. If it was a negative cosine, it would be upside down. If it was a negative sine, you would flip it. So understanding this is imperative to understanding pretty much the rest of chapter 4.
Okay, so then the sine starts at the midline, and then the cosine starts at the maximum.
Yes.
Okay.
All right, very important. I would do, you know, make sure before taking your midterm, not final, that you do all the homework associated with chapter 4. And every chapter, it's 1 through 4, and chapter 3 is abbreviated. There's only 2 sections in chapter 3. Okay, so anything else on secant and cosecant functions? So with that, now I know you have another chance on Thursday to ask more questions before the exam, but I have this review packet that, and I know I've said this repeatedly, but I have this PDF copy that has, you know, all these questions, and it has answers in the back. So make sure that when you're doing it, if you can do it on Math Excel, but I would want you to ask questions on this hard copy. There's 37 questions, and they give the answers at the end. So I'm in the answers right now. They give you, you can check your work and see if you got them right. Refer to this, and then if you have questions, which you can right now, we're going to refer to this PDF document, because the numbers, if you do it in Math Excel, will change. Like this 8x or negative 8x could be a 20x. So I just want us to all be looking at the same problem. Okay. Do we have questions on the review packet at this point? There are 37 questions, anything 1 through 37 that I could go over. Maybe we're not ready yet. Maybe we haven't looked at it yet.
Yeah, no, I'm still trying to get through the rest of the homework. I'm like behind in the homework because it's taking me forever to do. So I haven't even looked at this.
Okay.
I just printed it out though, so I mean, I have it.
All right, so luckily there's no more new material, right? The end of the material is 4.4. So at this point, if I were you guys, I would study because you could still ask questions on Thursday. I would study all the way up to Thursday, ask whatever questions that you know you have on Thursday, but then, the exam opens. So at that point, I'm going to close it, or I'm going to close the questions, but yeah, if anybody has questions, I'm happy to answer them now or via email. But once the exam is out, then you guys are kind of on your own. So I want to say that if people feel, because it's online, that it's harder, I get it. Some students have a completely different point of view. They would prefer it online. I don't know where I fall in that category. I personally, if I was given, I just know from my own experience that the fact that you guys have the unit circle on hand and you don't have to memorize it, and your notes and everything, like that's a major advantage. But then the people who, which I've heard from people, that you want to be in person, I get it. It's hard. This is going to require an extra push for people like that, that they don't want to be online, and it's tough. And I do support you. I just want you guys to know I am here for you. I am answering questions. Yes, it does move fast. I don't want you guys to feel horrible in this class, and I know you're busy, and we all are. But yeah, it's not necessarily gonna be easy. If you have questions, please take the time to ask them, and I'm happy to be there for you guys.
Well, and I think the other point to make, because I saw some of the comments about, we get all these packets, not everybody just got out of high school. Not everybody knows how to do math that well, or gets it right away. And I think that that's really important for like everyone to understand that, people's math skill level is not the same, or aptitude. I mean, I think I'm not terrible at math, but I'm certainly not going to be any math major. So, it's important to like recognize that.
I do. And I went back to school, and I was one of those students. It was horrible. I will never forget it. So trust me, you have my sympathy on that. There's no doubt. There's no doubt. And this is not easy. You're in an online setting now. And, I just got certified to teach online, and it takes a certain type of student to be okay with it. So, and right now nobody chose it, and I get that. So, but please understand, I am here to support you guys. I am giving you guys material. I know it's a lot. Pick and choose what works for you, okay?
Mm-hmm.
All right, so if there's no more questions on this, we can end, but come on Thursday and make sure you have questions ready to go from this review guide, okay?
I have one more thing. So this midterm review that came from Math Excel, I mean, like, is pretty much the midterm going to like not mirror it exactly, but like, I mean, the questions there's not going to be like left field questions. Is there? Like, we can study from this and like be okay to do the midterm?
I would study from this. I'm trying to think if there,
like, as opposed to studying from all these packets, you know what I mean?
Well, I would hope, I already said in the beginning of this that I would have like quote unquote packets like this. If you call this a packet, I would have this open. I would have this open. Like I said earlier, I shared my screen. To do that again real quick. Like, I would pull up this exact thing. This was chapter 1. And I would just have them all ready to go so that I could quickly say, oh yeah, that's what that is. I mean, I know it's a lot, but hey, if you get it together and organize yourself, you're going to have every advantage possible. But
yeah, well, that's what I'm trying to do, because I'm going to have to, like, that's how it's going to have to be tackled. So
have these up and ready while you have your test open. But I was going to say, example, like, this is a similar triangle problem. And I'm going to give you a similar triangle problem, but it's not going to be the same as this one. So it will incorporate similar triangles, and you'll have to draw similar triangles based on the scenario. So just keep that in mind. But that's an example. A lot of them are going to be just like this. Definitely a question like this one number. I mean, a lot of them are literally, just like this. I would study this 100%, go through it. I'm trying to think. questions that are like these questions that are maybe not 100% the same. Here's all the graphs. Go through this. I'm trying to think what might be a little bit different. It can't be identical, right? Because that would be foolish.
Well, right, obviously.
Alrighty, so if you do have any questions on here, first of all, feel free to email me in the next couple days, because then I could call them out and be ready to talk about them on the Zoom call. So that if you have them in advance, that would be good.
Alrighty.
Okay, anybody else questions? You feel free to email me if you have any. All right, we'll see you guys on Thursday then. All right, see ya.